Okay, 9 honors kids, this is Unit 1, Lesson 5. All right, the topic is factoring. Okay, by splitting. And solving quadratic equations by factoring. Okay, and then the other thing that you're going to have on this is completing the square. I don't know if you remember that, so I'll remind you how to do that just in case. All right, so this is going to be like a mix of things. Okay, so example 1. Okay, let's see if you guys can figure out a plan for how you would do something like this. We want to factor this. Factor 12a cubed minus 4ab minus 9a plus 3b. Now, keep in mind, things need to match. So sometimes you're going to have to switch the order around in some of these more complicated problems. Okay, let's see if it just automatically works. So if I take out a 4a on the left, I'm left with 3a minus b, right? I need this to match. Can I get that match? Yes, I can, right? By putting a negative 3 outside. So this is just 4a minus 3 times 3a minus b. Okay, let's look at the next one. 2x cubed minus 8x squared minus 2x plus 8. So let's see if this works in the order of the question. So if I split this down the middle, okay, will it just automatically work? So if I take out a 2x squared, I'm left with x minus 4, right? Then if I take out a negative 2 here, I'll be left with the x minus 4. So I have, I could have taken out a GCF first. Well, doesn't matter. 2x squared minus 2 times x minus 4. So now I'll take out the 2. X squared minus 1 times x minus 4. And then we have a dots here, right? X plus 1, x minus 1. Okay, so that's how you would factor that one completely. All right, let's take a look at number 3. This one's going to be very long. 3x cubed minus x squared y plus 6x squared y minus 2xy squared plus 3xy squared minus y cubed. Okay, so for this one, we're going to have 3 different factoring by grouping. All right, we're going to be splitting this up 3 different ways. All right, so 1, 2, 3. Okay. So, I mean, these have to have a GCF. So sometimes, I'm just letting you know, sometimes you're going to have to switch this order around because the terms should have a GCF. And you need the other parts to match up. So if they don't match up, sometimes you're going to have to do a little bit more work. So be prepared to expect the unexpected here. All right, so on the left here, we could take out an x squared. We're left with 3x minus y. So our goal is to get these to match, 3x minus y, 3x minus y. If they don't match, sometimes you have to fiddle with it and move things around because you're trying to get these to match. Okay, so you probably paused it there and made sure that made sense to you. So now I have x squared plus 2xy plus y squared And do you recognize that as a perfect square trinomial by now? So that is just the square of x plus y. And then I have my 3x minus y. So that would be your answer. All right, let's take a look at a couple more. I have, this is example 4. I have x plus 4 cubed minus 9x minus 36. So if you look at the structure of this, right, you want to think about how you can split this up. You want to have things that are going to be identical, right? You want to have a common factor. So this is one where you have to think outside the box. If I take out a negative 9 here, don't I end up with x plus 4? So then wouldn't x plus 4 be my GCF? And then I'd be left with an x plus 4 squared here, right? Minus 9. You might want to pause that and digest that, okay, because you have to look for patterns. So you have to be aware of these. Not as easy as you think. You really have to think outside of the box for a lot of these questions. So you have x plus 4. Now, this is dots, right? This is difference of two squares. So x plus 4 minus 3 times x plus 4 plus 3. So that's just x plus 4 times x plus 1 times x plus 7. Tricky. Let's take a look at number 5. So number 5, we have x squared minus 6x plus 9 minus 4y squared. So do you see that this is a perfect square trinomial? So this is x minus 3 squared minus 4y squared. So now it's actually dots. So you get x minus 3 plus 2y, x minus 3 minus 2y. So that's going to give you x minus 3 plus 2y. It's the same thing, so that doesn't matter. All right. Okay, hopefully most of most of this next part is going to be review, but it's going to be lengthy. Feel free to fast forward through whatever you do remember, okay? But I am going to review it for some students that need it. So we're going to be solving quadratic equations. So let's say we have x squared minus 3x equals 18. So you need to get everything to the left. I don't need to see you getting the 18 to the left. You need to factor. So you have two numbers which multiply to negative 18 and add to negative 3. Then you use what's called the zero product property. That means that in order for a product to equal 0, either one or both of the factors here would have to be 0. So you set each equal to 0, and then you solve. So you get x is 6, x is negative 3. So that would be your solution. So the solution set is 6, negative 3. Okay, you can also use the quadratic formula, by the way. X equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. This will give you the roots as well. So we have negative b would be 3, plus or minus the square root, negative 3 squared. You can just write 9, minus 4 times a times c, over 2a. So you have 3 plus or minus square root. Well, 4 times 18 is 72, right? So you have 9 plus 72 divided by 2. So that becomes 3 plus or minus the square root of 81 over 2. And then you split this up. So you have 3 plus 9 over 2, which is 6. And then you have 3 minus 9 over 2. Well, 3 minus 9 is negative 6 over 2 is negative 3. So you can always use the quadratic formula solve. It's just that it's lengthy, time consuming, and you can make careless errors. Factoring is easier. It's cleaner. Let's take a look at another one. We have, okay, a perfect square trinomial. Okay, a perfect square trinomial is going to be a double root. That's what's going to happen. So when you go to solve this, right, you get y minus 3 squared. So there's two factors, but they're the same factor. So you just get y is 3. You don't need to write the 3 twice, so the solution set is just 3. It's called the double root. You'll understand this more when we do the discriminant. All right, let's say you have 6x squared plus 5x equals 4. Bring the 4 over. 6x squared plus 5x minus 4 equals 0. Now you can always do trial and error, by the way, to get these factors. Okay, but since I taught you how to do it this way, I need two numbers that multiply to negative 24 and add to 5. So that's 8 and negative 3. Replace it, split it down the middle. Take out your GCF. Get this to match. And then set each factor equal to 0. Solve, solve. You could solve it as fast as you want. And so those would be your solutions. Negative 4 thirds and a half. Okay, so keep that in mind. You could also end up with 3 roots. So let's say you have m cubed minus 5m squared minus 14m. So you'd have to take out your GCF first, right? So then you'd have m squared minus 5m minus 14. Factor that. M minus 7, m plus 2. Don't forget your m. So now for the zero product property, you have 3 answers. 0, 7, negative 2. That would be your solution set. Okay? All right. Now, other things that you want to keep in mind is you could have a simple equation, which might not be so simple. Let's say you had something, I call this the square root method. So if you had something like solve 9x squared equals 49, you don't need to factor here. All you have to do is divide both sides by 9 and write x squared is 49 over 9, and then x is plus or minus the square root of 49 over 9. So things like this can happen too, guys. So that's 7 thirds plus or minus 7 thirds. Okay, so just keep that in mind. You could also have simplifying a square root. There are a lot of things that can come up here that are all considered review for 9 honors. So you get double squared, w squared is 40. When you go to get the plus or minus square root, you make that the square root of 4, square root of 10, which is 2 rad 10. Okay. If you don't remember how to simplify square roots, you could certainly, Google a video. That's one way to do it. You can go back, look in your notes from last year, right? There's always ways that you can do it. Be prepared to have to solve word problems. Okay, like for instance, here's a word problem. The sum of the squares of 2 consecutive even integers is 52. What are the integers? So since they're even, you have x and x plus 2. and then it's the sum of their squares. So x squared plus x plus 2 squared, 52. Now do it out. X squared plus 4x plus 4 minus 52 equals 0. So you end up with negative 48 here. Combine like terms. Take out your GCF. And so you end up getting x plus 6, x minus 4. You just divide by the 2. You don't have to worry about that. So now you need to think about it, though. It says the sum of the squares. So here I got a negative 6, right? And then here I got a positive 4. So there's 2 sets of answers. If negative 6 were the answer, then the next one would be negative 4. So you have negative 6 and negative 4. Go back and substitute into your let statement, right? This is the first consecutive even integer, second consecutive even integer. And then if you got 4, you would have 4 and 6. So there are 2 sets of answers for that question. If they would have worded it as the sum of the squares of 2 positive consecutive even, then we would just have this answer. If they said the sum of the squares of 2 consecutive negative even integers, that would be the answer. But here they generalized, that means you need both sets of answers. All right. The last thing that you need to know that you haven't done in a long time, okay, is completing the square. So I'm just going to remind you how to do that. You are allowed to do that if you wish. Okay, it's not mandatory. Usually there's another way of doing it, but just in case, you should review it. So it's expected when you come into 9 honors that you know a lot of this. Okay, I just assume that somebody in the class doesn't know something, so I'll review it. But as I said, you could fast forward this. Okay, solve by completing the square. I'm abbreviating, I know. Y squared minus 12y plus 27 is 0. All right, so I'm going to kick the 27 to the right of the problem. Then I'm going to complete the square. So to complete the square, I need to take half of negative 12. Okay, so I'm going to get y squared minus 12y. So I take half of negative 12. I take that answer and I have to square that answer. You're always going to get a positive, guys. Always. 100% of the time. All right, and this is a skill you need through calculus. There will be problems. You will not be able to integrate certain problems if you don't know how to complete the square. All right, so on the left, this is now the square, because we completed the square. So it's the square of y minus 6. On the right, we just end up getting a 9. So now what you do is you take this, and you know that you get the square root of both sides, right? But this would be plus or minus the square root of 9. So you get y minus 6 equals plus or minus the square root of 9. Y minus 6 equals plus or minus 3. And then, okay, hold on. My hand just moved this. Oh, well, whatever. So now I'm going to add my 6. So I'm going to get y equals 6 plus or minus 3. Follow that through. There's 2 answers. 6 plus 3, 6 minus 3. So that would be my solution set. 9, 3. When you write a solution set, it's not an ordered pair, kids. So you can write it in whatever order that you want. Right, so we will be practicing this more. If you need more practice on anything besides, what I do in class, feel free to ask me, what book can I look in, what pages, you could try that. And there's always websites, you can always, Google websites, and don't forget that you can use the quadratic formula as well. So, there are all these things to keep in mind. I guess I'll do one more quadratic formula just to have your back, okay? All right, solve using the quadratic formula. So let's say we have 4q squared plus 1 equals 2q squared minus 6q. I'm going to bring everything to the left. So I get 2q squared plus 6q plus 1 is 0. So this is my value of A, this is B, this is C. So I substitute in, I have x equals negative b plus or minus the square root of b squared minus 4 times A times C, all over 2A. So I end up with x equals negative 6 plus or minus the square root. I have 36 minus 8, which is 28, over 4. Be prepared to have to simplify this, so you get negative 6 plus or minus the square root of 4, square root of 7 over 4, which is negative 6 plus or minus 2 rad 7 over 4. Then you have to look at all three of these numbers and see if they have a factor in common. It has to be all three. I'm sure you remember that from last year. Don't know what I just did there, but that was so much fun. All right. So I'm going to divide them all by 2. Negative 3 plus or minus the square root of 7, because that coefficient becomes a 1, all over 2. So my solutions are negative 3 plus rad 7 over 2. These are irrational. 2 real irrational roots. Negative 3 minus square root of 7 over 2. And that would be the solution set. Okay. I hope this helped.